Hey everybody, this is Shannon Finks with the Finks 5. This is where I and my students review a therapeutic topic within 5 to 15 minutes or within 5 points. And today we're going to talk about understanding and assessing lipids in a patient who may be presenting to you in clinic. So, cholesterol, triglycerides, and phospholipids are the major lipids in the body, and they are transported as lipoproteins. This is essential because the cholesterol itself is lipophilic. Those lipids are lipophilic, and they need to cross the cell membrane, and on the outside surface of the phospholipid is more water soluble. So they float around in the serum as lipoproteins, delivering cholesterol esters and triglycerides to the cells that are needed, and they deposit those as needed. On the surface, the phospholipid is present, and also you have apolipoproteins, which inform structure and function of that cell. And we'll come back to that in a moment, but I like to think of apolipoproteins as the Uber driver and the lipoproteins itself as the car that drives around the bloodstream. So lipoproteins come in different shapes and sizes, and that is depicted upon this slide. And chylomicrons and chylomicron remnants are very much triglyceride rich or triglyceride dense. This is what is taken up by the liver, and then the liver processes this form of lipid and creates VLDL, IDL, LDL, which serves a certain function in our body. But the relative density of each of these lipoproteins is determined by the content of both lipid and protein that each contain. And I want to point out just a couple of key concepts here, that the very triglyceride rich, again, are the chylomicron remnants and chylomicrons and VLDL for that matter. LDL are low density lipoprotein, is more atherogenic, but so is intermediate density lipoprotein. And I'd like to point out that non-HDL cholesterol, all of these LDL, VLDL, IDL, triglycerides, chylomicron remnants, chylomicrons are all, they can be calculated by the total cholesterol minus the HDL. This is representative by the non-HDL cholesterol. And all of these lipoproteins, these varying different shapes and sizes of non-HDL cholesterol, are mediated by apolipoprotein B. These are all your atherogenic lipoproteins. In contrast, HDL, or high density lipoprotein, is mediated by apolipoprotein A, and it also is involved in what is called reverse cholesterol transport. And this is the process for where molecules produced by the liver in excess are transported back to the liver for recirculation. Cholesterol is absolutely important. It's important for cell wall structure. It's important for making our sex hormones, our cortisol. It is essential, but imbalanced cholesterol or imbalanced lipoproteins can cause oxidative damage. And so chronic hyperlipidemia is this trigger for endothelial injury, and it can be caused by genetics, it can be caused by environment and our intake, but what results is increased permeability into the intimal layer of the arterial wall, forming fatty streaks and plaques that can lead to a progression of coronary or cerebrovascular or peripheral vascular disease. And we think a lot about LDL and how elevated LDL or a reduced HDL is the culprit for coronary heart disease. And perhaps that a higher HDL has an anti-atherogenic effect, but in reality, imbalances in these other non-HDL cholesterol lipoproteins can also lead to atherosclerosis. But the point here is that any imbalance can cause oxidative damage and place a person at risk for heart events, for stroke events, for amputation from peripheral vascular disease as well. I like to show this graph because this iterates the point that it's not just LDL or bad cholesterol and HDL good cholesterol. And in fact, what this is showing you is that as triglycerides increase in concentration, and you see this along the bottom axis of the graph, the pattern shifts from a large, very buoyant cholesterol to one that is smaller and dense, and pattern B, apolipoprotein B, or pattern B, which is smaller, dense LDL, occurs. And this is thought to be important in cardiometabolic risk. That's why we take into consideration triglycerides. This is why triglycerides are considered in the diagnosis of metabolic syndrome. This is why cholesterol guidelines include Visipa when triglycerides are above a level of 135 or 150, depending upon the guidelines that you look at. It is a shift in the atherogenic cholesterol particles that occurs when triglycerides are higher. So LDL particle size actually plays a role in atherosclerotic risk, and the particle size just refers to how big or how small the LDL is. And so this is a pattern A, if you will. This is a large buoyant LDL molecule, and that red wraparound is the apolipoprotein B, for example. It's the Uber driver of that LDL car, if you will. And you notice that the LDL cholesterol is 100 milligrams per deciliter, but the particle size is big. I want you to think about this as a big school bus that just drives around the bloodstream and will park itself where it's instructed to do so to let out cholesterol esters and triglycerides as forms of energy to the organ that it is called to. And the apolipoprotein B there has a particular weight as well. And you know from guidelines, we want the apolipoprotein B to be less than a certain level and the LDL to be less than a certain level based upon that person's underlying atherosclerotic risk. So when you have higher triglycerides, though, that burden changes, remember from the previous graph, and what happens is that smaller LDL or pattern B tends to appear. And so I want you to think about these as Mini Coopers, if you will. So it goes from the big school bus to the little Mini Coopers. And as a result, the LDL the LDL concentration may stay the same, but look at the particle size here. This is 1800 millimoles per liter. There's more of these little Mini Coopers than the school bus, and also each one of them has to have their Uber driver, their apolipoprotein B, wrapped around it, and as a result the apolipoprotein B concentration is also higher. This is a higher risk for atherosclerotic disease, where lower triglycerides will keep it more as a large, more buoyant pattern A. This animation shows the difference between someone with a larger pattern A lipoprotein size, which went through the bloodstream very efficiently there, than someone who has a smaller, dense pattern B. And in someone who has a smaller pattern B, that lipoprotein gets oxidized. And the reason is because the LDL receptor does not recognize small, dense pattern B lipoprotein almost 30 to 40% less than it recognizes the large, buoyant pattern A lipoprotein. The end result is that the smaller, more dense lipoprotein particles get oxidized, and when they are more oxidized, they infiltrate the intimal layer of the vascular wall more efficiently. And when a molecule or lipoprotein becomes oxidized, it will destroy more when it touches that vascular wall. It is more atherogenic. And because of its smaller size, think of a parking space. It's much harder to park a big school bus into a parking space along the highway than it is a small Mini Cooper. And use that analogy to understand that small, dense LDL is more atherogenic. So small, dense LDL, or pattern B, is more susceptible to oxidation, and when it oxidizes, it causes tissue damage. The small, dense LDL enters that arterial wall 40% faster than large, buoyant LDL, and small, dense, or pattern B binds poorly to the LDL receptor so that it stays in the bloodstream longer, causing prolonged residence in the plasma, and therefore it can cause more damage, more atherogenic damage. When we in clinic draw a lipid panel, we can draw a fasting or a non-fasting. The 2018 ACCHA cholesterol guidelines say that non-fasting is acceptable for most situations. We are going to begin at age 20 though, and we may repeat that lipid assessment every 5 years, or in someone who's at a higher risk, as is someone who is obese or who has any insulin resistance, i.e. someone who has higher triglycerides, we may repeat that testing more often based upon their underlying risk. And we're going to use that cholesterol information to develop a prevent score or an ASCVD risk calculation. We may start with a non-fasting lipid panel, and remember that's a really good measurement of our HDL cholesterol and our total cholesterol, but the triglycerides will be affected by food. And so if you find someone who has a higher triglycerides on a non-fasting panel, we may want to recheck a fasting lipid panel. The other thing is that you want to remember that LDL here in most lipid panels is calculated, and that's calculated based upon the Free-Wald equation, which triglycerides are a component of. And so this becomes less reliable when you've got a really low LDL or when triglycerides are really high. And in that case, you can draw a direct LDL measurement if needed. You may also see that we draw an apolipoprotein B or an ApoB level, which according to guidelines is an appropriate measurement to measure all of the atherogenic lipoproteins, because remember, apolipoprotein B is that Uber driver that informs all of the atherogenic lipoproteins. Lipoprotein little a is a new molecule that is genetically determined, and it is a bad guy. It is not only atherogenic, but it's also thrombogenic, and it when elevated has been shown to increase risk for atherogenic events like stroke and MI, and we may draw a lipoprotein little a level as well in some patients. This is just an example to show you how food may affect your triglycerides, and again, that glucose and triglyceride burden will cause triglycerides to be higher on a non-fasting lipid panel. This is an example of a report that may come back from a more extensive cholesterol draw, like we use the Cleveland Heart Labs in some patients with increased atherosclerotic burden or a significant family history where we want to dig a little bit deeper. But this also shows apolipoprotein levels and shows that this particular patient has an elevated lipoprotein A. And this is even a more extensive report from Cleveland Heart Labs where we actually look at particle size, the LDL particle size, and we look at the components of small, dense LDL cholesterol here. This also includes some inflammatory markers that are important because it is not cholesterol that influences mortality. It is the inflammatory cholesterol that more influences whether or not this patient may have an acute event. And so this shows that we can easily assess this with a Cleveland Heart Lab sample. So, in summary, lipoproteins are essential for bodily functions such as cell membrane synthesis and sex hormone synthesis. They come in different shapes and sizes, which account for their roles, their differing roles, and their atherogenic risk. It is the inflammatory lipoproteins that cause oxidative damage and increase risk for heart event or stroke. It's not just the LDL and HDL, and understanding when and how to obtain a lipid panel and then how to read that lipid panel will help you assess your patient's risk. I tried to get this all in 15 minutes. We're a tiny bit over, but thanks so much for your attention with this Finks 5.